One of the very first steps in any network reconnaissance mission is to reduce a set of IP ranges into a list of active or interesting hosts. Scanning every port of every single IP address is slow and usually unnecessary. In No Port Scan option, using SN option, which was known as SP in previous releases, you tell Nmap not to do a port scan after host discovery, and only print out the available hosts that responded to the host discovery probes. This scan type is often known as a ping scan. Systems administrators often find this option valuable as well. It can easily be used to count available machines on a network or monitor server availability. This is often called a ping sweep and is more reliable than pinging the broadcast address because many hosts do not reply to broadcast queries. The default host discovery done with SN is executed by a privileged user. It sends an ICMP echo request, TCP SYN packet to port 443, TCP ACK packet to port 80, and an ICMP timestamp request by default. When executed by an unprivileged user, only SYN packets are sent using a connect call to ports 80 and 443 on the target. When a privileged user tries to scan targets on a local Ethernet network, ARP requests are used unless send IP was specified. Let's perform the first Nmap scans of the course using ping scan, also known as No Port Scan. Nmap is embedded in Kali and defined in the path, so you can run Nmap from anywhere just by typing Nmap in a terminal screen. When you type Nmap and hit Enter, you get the help page of the Nmap. You can also look at the man page by typing man Nmap to learn more. Let's build an Nmap command to perform a ping scan. After the command itself, Nmap, I first add the parameter to define the scan type as ping scan. Note that the order of the parameters is not important in Nmap. Now, enter the only mandatory parameter, IP address. Here I enter 172.16.99.0/24. Network gurus already know what it is. Keeping it very simple, it means the IP addresses between 172.16.99.0 and 172.16.99.255. That's enough. Hit Enter and run the command. And the results are in. These are the hosts which are up. That means these are the systems that responded to our requests. Remember from the previous slide, our requests are ICMP echo, SYN for port 443, ACK for port 80, and ICMP timestamp requests, if the user is privileged. The IP addresses or the domain names of the systems are spread across the lines. In most cases, we want to see the IP addresses of the hosts as a list to use in further scans. So what can we do to see only the IP addresses of the live systems? Well, we're going to use the power of the Linux command shell. First, let's clear some lines of the result which do not contain IP addresses. So we'll only have the lines of IP addresses. To be able to do this, I'll use grep command with pipe. Copy a static part of the IP lines, for example, nmap scan, and give it as the parameter of grep command. Let me give you a little tip here. If you're using a mouse, select a string in the terminal screen and press the middle button of the mouse to copy and paste the selected part. Now we only have the lines which contain the IP addresses. But wait a second, we have a domain name of a host. Let's get rid of the domain name and see only the IP address of it. In nmap command, add -n parameter to avoid the name resolution, so nmap will display only the IP address. Now we have the lines with IP addresses. Now the second step is to clear the words in the lines to have only the IP addresses. To do this, we'll use the cut command of the Linux shell. Type cut. The delimiter here is the space character. Give it with the D parameter. IP is the fifth field of the line. Give it with F parameter. Now we have the IP list of the live hosts. Port Scan with Nmap allows you to discover which TCP or UDP ports are open on your target host. Network ports are the entry points to a machine that is connected to the Internet. A service that listens on a port is able to receive data from a client application, process it, and send a response back. Malicious clients can sometimes exploit vulnerabilities in the server code so they can gain access to sensitive data or execute malicious code on the machine remotely. That is why testing for all ports is necessary in order to achieve a thorough security verification. Port scanning is usually done in the initial phase of a penetration test in order to discover all network entry points into the target system. Port scan takes the biggest part of our Nmap lectures. In what I would call the most basic port scan types lectures, we see the following: Nmap options of port scanning, SYN scan, TCP scan, comparison between the SYN scan and TCP scan, UDP scan, and some other types of port scans. SYN scan is the default and the most popular scan option for good reasons. It can be performed quickly, scanning thousands of ports per second on a fast network, not blocked by restrictive firewalls. It's also relatively stealthy, since it never completes TCP connections. It also allows clear, reliable differentiation between open, closed, and filtered states. This technique is often referred to as half-open scanning, because you don't open a full TCP connection. You send a SYN packet, as if you're going to open a real connection, and then wait for a response. A SYNAC indicates the port is listening, or open, while a RIST, reset, is indicative of a non-listener. If no response is received after several retransmissions, or an ICMP unreachable error is received, the port is marked as filtered. If you receive a SYNAC from the target system, you send RIST instead of the ACK packet, and you do not complete the three-way handshake. Okay, so let's perform an Nmap SYN scan in our virtual network. Go to Kali and open the terminal screen. First, let's look at the IP address of Kali to understand the IP block. Here, my IP block is 172.16.99. This is because the net mask is 255.255.255.0. I don't want to go further into network basics in this course. You know what? Okay, fine. I'm going to add an IPv4 document to the course resources. You can look it up there. Now, let's create the SYN scan command. Nmap is the command itself. S is to SYN scan. Since it's the default scan type for privileged users, and I'm already a privileged user in Kali, this parameter is not necessary for a SYN scan. Now, here is the target IP block, 172.16.99.024. As we talked about before, remember, this is the IP address block from 172.16.99.0 right the way through 172.16.99.255. And let's keep it a fast scan for just the top 50 ports. I use top ports parameter for this purpose, and hit enter. Now let's look at the scan results. Here we have the computers who have the IP addresses 172.16.99.1 and 2. These are the gateway and the DNS server for my virtual network, VMnet. Ignore them for now. In fact, 1 is my host machine at the same time. Here there is a system, and the open ports are in the top 50. Oh, look, there's another machine, and of course, it's open ports. The machine with IP254 is the DHCP server of my VMnet, so ignore that as well. And the last machine found is the Kali itself. Okay, let's open Wireshark and see what's happening when a SYN scan is performed. Run Wireshark first. Double-click ETH0 to start to listen to that interface. Now to skip the packets, which we are not interested in, I add a filter. I only want to see the traffic for my destination computer, 172.16.99.139. And I want to see the TCP traffic only. Click the blue arrow next to the filter bar to activate the filter. OK, now go to the terminal screen. I'd like to analyze the SynScan packets for an open port first. 172.16.99.139 is my destination system, and I know that port 80 of that system is open. Hit Enter and run the Nmap query. Yep, the port is open just as I remember. So now go back to Wireshark. I want to stop Wireshark by clicking the red square at the upper left corner to avoid unwanted packets. So here we have 3 packets. The first packet is from an arbitrary port of Kali to the 80th port of the system 139, the destination system. It is a SYN packet to start the 3-way handshake. The second packet is a SYN-ACK sent by the destination system. The third packet is a RIST sent by Kali. Because it's a SynScan, the 3-way handshake is not completed and corrupted by a RIST packet. Now I restart the Wireshark packet capturing to clean its screen by clicking the upper left blue button. OK, so this time I scan a closed port, for example, port 81. Now the first packet is a SynScan packet to start the 3-way handshake again. The source system is Kali, and the destination system is, again, 139. The second packet is, for this scan, a RIST packet. Because port 81 is closed, the destination system sent us a RIST packet. Let's see how Nmap interprets the results of SynScan. When we send a SYN packet, the destination system replies a SYN-ACK packet to show that it's ready for a connection. And we send RIST to corrupt the handshake. Nmap interprets this result as the port is open. If the destination system replies a RIST packet for our SYN packet, that means the port is accessible, but it's closed. If the destination system doesn't respond to our SYN packet, Nmap thinks that the packet is dropped or filtered. It's a common behavior of the firewalls. If the destination system replies an ICMP unreachable packet for our SYN packet, again, it's interpreted as filtered. This is another type of firewall behavior. Well, what do open, closed, or filtered actually mean? Let's take a closer look at the results of Nmap. When Nmap sends packets to a port and receives a positive response, the port is assigned the state of open. For example, SynScan receives a SYN-ACK from the destination system if the port is open. If Nmap determines that a port is not available, it assigns it the closed state. This signifies that Nmap has received a result that clearly shows that the port is closed. A SynScan receiving a RIST in response to a port query is an example of a closed port. Filtered ports are the result of a packet filter or firewall when no response at all is received from the remote device. The port is considered to be filtered. Since a response isn't received from the port, Nmap often retries communication to the port to ensure that the packet wasn't simply dropped due to error or congestion. Please note that this type of response is categorized differently if this is a different scan type, such as a UDP scan or a fin scan. The next result, open filtered, is coming in a minute. On the other hand, if the destination systems return an unexpected response, again the port is considered to be filtered. If we get an ICMP unreachable response in a SynScan, the port is flagged as filtered. Now, in some cases, the lack of a response may not necessarily mean that a port is filtered. Lack of a response might mean that the port might also be open. Now, in these situations, Nmap signifies that the port is either filtered or open. For example, in a UDP connection, in most cases, the destination system does not send a response when it receives a UDP packet. So if the destination system does not respond, Nmap categorizes it as open filtered. Make sense? In this slide, you see some of the most known default ports. So here's the question. If the port 22 is open, is the service running there absolutely in SSH? Could there be another service? Well, these are the default port numbers of the services. You can run any service in any port. You can run HTTP on port 22, for example. But for the ease of use, the default ports are used in general. So if you're performing a pen test, you should probably look at the well-known ports first, but you should never just scan the default ports. There are different ways to scan ports with Nmap. Let's see how we can scan ports. Let's prepare a SYN-scan for a Metasploitable device. The IP address of my Metasploitable is 172.16.99.206. If you do not use any one of the port scanning parameters, top 1,000 ports are scanned. Top ports are the most used ports in general. The first way of choosing the ports to scan is using p-parameter. After entering the scan type and target IP, enter the port numbers with p-parameter. You can enter ports one by one, separated by a comma, or you can give a range of ports by putting a dash between the port numbers. In this example, the ports 22, 80, and the ports between 100 and 200 are scanned. If you perform both TCP scan and UDP scan in a single Nmap query, you can choose both the UDP ports and the TCP ports using p-parameter. For this Nmap scan, we'll use both SYN-scan and UDP scan at the same time. We haven't seen it yet, but the UDP scan is performed using S capital U parameter. And as you know, the SYN-scan is a type of TCP scan. After entering the target IP, put -p. To enter TCP ports, put uppercase T with a colon just after the parameter P and the TCP ports to scan. Same as giving port numbers directly with p-parameter. You can enter ports one by one, separated by a comma, or you can give a range of ports by putting a dash between the port numbers. To specify the UDP ports, put U, that's an uppercase U, with a colon and the ports with the same format. For this example, let's scan the TCP ports 22 and 80, and the UDP ports 53, and the ports between 139 and 150. So here are the results, TCP ports first and then UDP ports. Another way to specify the ports is using top ports parameter. Using this with the number of ports that will be scanned, you can scan the top ports within this parameter. So let's scan top 20 ports for this example. So here are the top results of the most used 20 ports. If you use uppercase F, which means fast scan, top 100 ports are scanned. So let's perform an Nmap SYN-scan with F parameter here. And open another terminal screen and perform another Nmap scan using top ports 100 parameter. As you see, we get the same results because these are the same queries. If you'd like to scan all the ports of the system, well, you should scan all the ports of the systems in a pen test. You have to use the p-parameter with the interval from 1 to 65,535. This is the range of possible port numbers. Prepare the Nmap SYN-scan query with the destination IP address. Now put P1-65535 and hit Enter. Here are all the open ports of Metasploitable. By default, Nmap does host discovery and then performs a port scan against each host it determines is online. If you use pn in the Nmap query, you skip host discovery and port scan all target hosts. Disabling host discovery with pn causes Nmap to attempt the requested scanning functions against every target IP address specified. So if a Class C target address space, that means 24 is specified on the command line, all 255 IP addresses are scanned. Now, why would we want to do this? As you know, if you are a privileged user, Nmap sends 4 types of packets to discover hosts: ICMP echo request, SYN packet to TCP 443 port, ACK packet to TCP 80 port, and ICMP timestamp request. If a system is configured not to answer to ICMP requests, and if the ports 80 and 443 are filtered, then Nmap thinks that the host is down even if it's up. If you find a system which is not found by ping scan, always use PN for further port scans. Otherwise, Nmap doesn't perform the port scan because it assumes that the host is not up. So if your network is not big, or if you don't have enough time to scan, you should skip the ping scan and run the port scans for every possible IP address. Use the port scan instead of ping scan if you are scanning a server block, because those systems are configured to be more secure than usual. Then you can find more computers than the ping scans do. You're halfway there. TCP scan, also known as TCP Connect scan, is the default TCP scan type when SYN-SCAN is not an option. Well, when is the SYN-SCAN not an option? Do you remember the trip of data packet on a DNS query? In that lecture, I said that Layer 3 and Layer 4 packets are managed by the operating system of your device. That means user does not interfere with the TCP three-way handshake. The whole process is managed by the operating system itself. In a SYN-SCAN, we interrupt the three-way handshake and don't send the last ACK packet to complete the handshake. You have to be a privileged user to be able to interrupt the handshake. If you're not a privileged user, you cannot interrupt three-way handshake and cannot perform a SYN-SCAN as well. So instead of writing raw packets as most other scan types do, which needs admin privilege, Nmap asks the underlying operating system to establish a connection with a target machine and port by issuing the native connect system call. So you don't need to be a privileged user to perform TCP connect scans. When SYN-SCAN is available, it is usually a better choice. Nmap has less control over the high-level connect call than with raw packets, making it less efficient. The system call completes connections to open target ports rather than performing the half-open reset that SYN-SCAN does. Not only does this take longer and require more packets to obtain the same information, but target machines are more likely to log the connection, not too stealthy. The steps of TCP Connect Scan is exactly the same as TCP three-way handshake. You send a SYN packet to open a real connection and then wait for a response. A SYN-ACK response indicates the port is listening or open, while a RIST reset is indicative of a non-listener. If no response is received after several retransmissions or an ICMP unreachable error is received, the port is marked as filtered. If you receive a SYN-ACK from the target system, you send an ACK packet to complete the three-way handshake. Since we have nothing to say at the moment, we send RIST to end the conversation. Let's see what happens under the hood when we perform a TCP scan, and then compare the SYN-SCAN with the TCP scan. Let's perform an Nmap TCP scan in our virtual network first. Go to Kali and open a terminal screen. I want to scan my Metasploitable system. So let's check if the host is up first. I know the IP address of my Metasploitable VM, so type ping 172.16.99.206 and hit enter. Okay, we received response packets. The system is up. Let's create the TCP scan command. Nmap is the command itself. S uppercase T is TCP scan. N is to avoid the DNS resolution. I'd like to see the IP addresses. Uppercase PN is to avoid the host discovery. I already know that the host is up, although you should make it a habit to use PN while you're scanning a single system. Now we have the target IP address 172.16.99.206. And let's keep it fast. Scan for the top 10 ports only. I use top ports parameter for this purpose and hit enter. Here are the states of the top 10 ports of Metasploitable. 7 ports are open and 3 ports are closed. Okay, let's open Wireshark and see what's happening when a TCP scan is performed. So you got to run Wireshark first. Double-click ETH0 to start to listen to that interface. To skip the packets which we're not interested in, I add a filter. I only want to see the traffic for my destination computer, 172.16.99.206. And I want to see the TCP traffic only. Click the blue arrow next to the filter bar to activate the filter. To clear the packets we've already caught, I restart Wireshark packet capturing. OK, now go to the terminal screen. I'd like to analyze the TCP scan packets for an open port first. I'm going to run the latest Nmap query again, but this time I run the query for port 80 only. Hit Enter and run the Nmap query. Yes, the port is open as I remember. It's good to know I'm not losing my memory. Go back to Wireshark. I want to stop Wireshark by clicking the red square at the upper left corner to avoid unwanted packets. Now here we have 3 packets. The first packet is a SYN packet to start the 3-way handshake. It's from an arbitrary port of Kali to the 80th port of Metasploitable, the destination system. Second packet is a SYN ACK sent by the destination system. The third packet is an ACK sent by Kali to complete the TCP 3-way handshake. And the fourth packet is a RIST sent by Kali again to end the conversation. Now this time, I want to scan a closed port, for example, port 81. Before running the query, I restart the Wireshark packet capturing to clean its screen by clicking the blue button in the upper left corner. In the terminal screen, I hit Enter to run the query. As you see, port 81 is closed. Now let's look at the Wireshark interface to see what happened when we scan a closed port. The first packet is again a SYN packet to start the 3-way handshake. The source system is Kali and the destination system is Metasploitable. The second packet is, for this scan, a RIST packet. Because port 81 is closed, the destination system sent us a RIST packet. So here we have a comparison between SYN scan packets and TCP scan packets for an open port. In SYN scan, Nmap has corrupted the 3-way handshake by a RIST packet. In TCP scan, on the other hand, the 3-way handshake is completed and the communication is established. So let's see the differences between the SYN scan and the TCP scan in a table that we've only really talked about up to now. 3-way handshake is not completed in SYN scan while it's completed in TCP scan. A RIST packet is sent when a SYN ACK is received in SYN scan, while an ACK packet is sent in TCP scan. Target machines are more likely to log the connection when the connection is established in TCP scan. No log for SYN scans because 3-way handshake is not established. Because the native operating system call is interrupted, SYN scan has to be run by a privileged user. TCP scan uses the system call, so it does not need extra privileges. UDP scan is activated with the S_U option. UDP scan works by sending a UDP packet to every targeted port. For some common ports such as 53 and 161, a protocol-specific payload is sent to increase response rate. But for most ports, the packet is empty. Well, there are some options to force Nmap to send non-empty packets such as data parameter. Because UDP scanning is generally slower and more difficult than TCP, some security auditors ignore these ports. Now, I think this is a mistake, as exploitable UDP services are quite common, and attackers certainly don't ignore the whole protocol. So in general, destination systems do not respond when they receive a UDP packet. So Nmap doesn't recognize if the port is open or filtered when there is no response from the target system. In this case, the port is flagged as open or filtered. To force the systems to respond to our packets, you'd be better off using UDP scan with version detection option. You'll have much more accurate results. Let's perform an Nmap UDP scan in our virtual network. Go to Kali and open a terminal screen. I want to scan my Metasploitable system. Let's create the UDP scan command. Nmap is the command itself. N is to avoid the DNS resolution. I like to see the IP addresses. Uppercase PN is to avoid the host discovery. We've seen these before. S_U is to do the UDP scan. Now here's the target IP address, 172.16.99.206. So let's keep it fast, scan for the top 10 ports only. I use top port's parameter for this purpose. Now, as I said a minute ago, UDP scan should run with version detection. Use S_V parameter to use the version detection. I'd like to add one more parameter here, which is reason. Reason parameter is used to show the reason why the state of the port is set as open, closed, or filtered. Now hit enter. See what I mean? UDP is much slower than SYNSCAN or TCP scan because the destination system does not respond in most of the time, and Nmap has to wait more to decide the states. And moreover, we use version detection, which sends more packets to understand the service and the version. So this scan takes much longer than the SYN or TCP scans. One IP address and 10 ports scanned in about, 100 seconds. Wake up if you took a nap. Here are the states of the top 10 UDP ports of Metasploitable. Ports 53 and 137 are flagged as open because they returned UDP responses. And you see the version of the services listening to those ports. Port 138 is flagged as open filtered because there is no response. And the other ports are flagged as closed because they returned ICMP port unreachable errors. Let's see how Nmap interprets the results of a UDP scan. Occasionally, a service will respond with a UDP packet, proving that it is open. If an ICMP port unreachable error, type 3, code 3, is returned, the port is closed. Other ICMP unreachable errors, type 3, codes 0, 1, 2, 9, 10, or 13, mark the port as filtered. If no response is received after retransmissions, the port is classified as open or filtered.